Hello friends, today I am going to discuss day-night sound level. In the previous lecture we have discussed about the sound equivalent to pressure and second sound equivalent levels and sound level pressures, and we have discussed the different types of the sound levels which are starting from the 1 second to the 1 hour, and today we are going to discuss about what is day and night sound levels. DNL, that is day-night sound level. It is based on sound levels measured in relative intensity of sound or decibels on the A-weighted scale, that is dBA. This scale most closely approximates the response characteristics of the human ear to the sound. Any sound which is created from any source and crosses a medium, that is air, or crosses a barrier, it may be small or large, and finally reaches to the receptor and to the sound ear, and it is varied during the day and night. The higher the number on the scale, the louder is the sound. DNM represents noise exposure event over a 24-hour period, that is during a day and during night periods. The LDN is used for different noise sources, that is road, railway, and aircraft. Proposed by the US Environmental Protection Agency, this noise criteria, that is LDN, it is used for usually it is the measurement of the noise which is measured from the dense or small traffic areas, where the continuously noise is generated from the various sources, or it may be a vehicle, it may be a small vehicle, passenger vehicle, or it may be a number of vehicles, a traffic jam, railway stations, railway tracks, and aircrafts. The LDN is taken into consideration the different noise impacts according to daytime and day-night. These noise levels which are taken into consideration in the LDN, which also varies from time to time and place to place. And at times, if it is a industrial area, it must be that assuming that there must be the huge noise during in the night as compared to the day, but it is really occurred at those places where such sources are present. The night level considered a sensitive time where people need to be safeguarded is increasing by 10 decibel, which on the A-weighted scale. This is the equation which represents the noise levels during the day and night, and this equation is used to calculate the LDN. Now, talking about the general indicators of the LDN and Lnight. Okay, LDN is an A-weighted average level of the noise emitted in 3 periods. Day, that is from 7 am to 19 am on 24-hour scale, and evening from 19 hours to 23 hours on, and during the night it is from 23 hours to 7 am to morning, with the penalty of 5 decibel on A-weighted scale and 10 decibel on A-weighted scale respectively. Now, in this noise exposure which is measured during day and night, it is then in terms we say the noise pollution level, that is represented by MPL. The MPL is made up by the two terms. The first one is the average noise level or energy mean, and the second one represents the fluctuation of that level during the emission time. In the first one, we are taking a level on the average scale, a noise level, or we can say the sound energy in their mean, which emitted from a source and crosses a medium. Then in the second, it represents the fluctuations in those levels during the emission time from the generation to up to the source. When it reaches the source, or we can see the receptors here. Okay. The noise pollution level, or we can say NPL, was developed by Robinson in the late 60s. Schultz in 1972. The Ampl formulation Summers cannot similar, which where the K is constant, that is equal to 2.56, and standard deviation to LEQ, which we have already discussed in the previous lecture. And this is the equation which represents the noise pollution levels. It is represented NP, that is equal to equal to sound pressure plus K naught, sigma, where K is the constant. This value is already given. However, that is 2.56. When the distribution of the instantaneous aviated sound level is Gaussian, the noise pollution level could be expressed in function of some statistical noise levels, which are represented in these two equations. Thank you for watching this lecture.